All right, the last type of problem we're going to look at in this section is the logistic growth models. So a logistic growth model is a function that is in a written form that is similar to this, where y is equal to c, which is divided by 1 plus a to the e to the negative bt. You do not need to memorize this model. If you are asked a problem, they will give it to you. You'll see that in the homework as well. So we're going to look at example 6 together. Okay, so the score on a test is the test of dexterity is given by P of t, where we have 100 divided by 1 plus 19 e to the negative 0.354x, where x is the number of times the test is taken. Okay, we want to determine the initial score. Okay, so this is without taking the test, what is the baseline score? So we're looking for what is P of 0. So we're going to write down our P of t and then plug in 0 for t. So we have 100 divided by 1 plus 19 e to the negative 0.354 times 0. And we're going to simplify that. Remember, e to the 0 power is 1. So we'd have 100 over 1 plus 19. Well, 100 divided by 1 plus 19, or 100 divided by 20, is 5. So the baseline score is 5. Okay, this isn't like a test for school. This is like dexterity, so your ability to do something. Okay, looking at part 2 of this question. So it says, use the function to determine the minimum number of times required for the score to exceed 90. So let's set the function equal to 90 and then figure out what our t has to be. And then of course we'll know anything greater than that, we'd be good. So 90 is equal to 100 over 1 plus 19 e to the negative 0.345 times t. And we want to solve for t. So I'm going to multiply this denominator over so that we can get this exponential up in the top. So we have 90 times 1 plus 19 e to the negative 0.345 t is equal to 100. Dividing by 90, 1 plus 19 e to the negative 0.345 t is equal to 10 divided by 9. 100 divided by 90 is 10 ninths. Okay, then next let's subtract 1. So we get 19 e to the negative 0.354 t. So 10 ninths minus 1 would be 1 ninth. Next, we're going to divide both sides by 19. We get e to the negative 0.354 t is equal to 1 divided by 171. So we have the negative 0.354 t is equal to the ln of 1 over 171. So our t value after dividing and using our calculator is equal to 14.5244. So if we know that on the 14th and a half-ish time that it's taken, we get a 90. How many times would we have to take it to exceed 90? Well, it'd have to be greater than this 14.5244. So we're looking at t equal to 15 or more. So t greater than 15. Now the next question, or the next part of this question, is part 3, where it asks for what is the limiting value of the scores. Some of you may have seen limits before in your pre-calc, but I kind of doubt it since most of y'all took that last year, and that's about the same time that COVID hit, that you should have been covering it. So this is not quite a limit, but it's the same process of thinking of a limit. So a limiting value is thinking this way. If I take my x value and I make it as large as possible, so if we just keep on getting bigger and bigger, what is that going to do to my whole function? So I'm going to write down our function and then we'll talk about it some. So we have that p of t is equal to 100 divided by 1 plus 19 e to the negative 0.354x. So we want to think as x goes to infinity, so as x gets larger and larger and larger, what is its effect on the rest of our function? Okay, so if we set x huge, it could be any number. What's it going to do to this e to the negative 0.354? So as x goes to infinity, e to the negative 0.354x will go to 0. Why is this? Well, this exponent here, as it gets larger and larger and larger, so as x gets larger and larger, this is going to get closer and closer to, shoot, I just lost my train of thought. It's going to make this bigger, which is going to, since it's a negative, it's going to make our denominator smaller. Remember, e to the negative power be 1 over e to the negative 0.354x. Okay? E to the positive 0.354x. So as this x gets larger, that's going to make this denominator get larger as well. But 1 to anything bigger, it's going to get smaller and closer to 0. So think about it this way. We have 1/2 and 1/3. Which one's smaller? 1/3. Keep going. 1/3 to 1/4. 1/4 is smaller. So the larger our denominator is, the smaller our fraction is going to be. So that's why we say that this approaches 0. Okay, so next we can plug in a 0 for this part of our function to figure out what the rest of our function p of x is doing. So if we have 100 divided by 1 plus 19 times 0, well, this is 100 divided by 1, which is equal to 100. So its limiting value is 100. Okay, I want you to try the next example on your own where it is similar to this problem and one other that we've done together combined. I know this limiting value is a little bit difficult. It's more conceptual than it is actual math. So I want you to be familiar with the limiting value because it will be useful in the next math class as well as in statistics. But it won't be on this first chapter 4. If it's on a test, it'll be on the final, which will be after the break. So we can talk more about this when I'm back if need be. All right, so this is all of this section minus the couple of examples that I've asked you to do for practice on your own. I will be posting a copy of my filled out notes that I've done along in the videos and including the several problems that I've asked you to do so that you can practice independently and then automatically get a check back. Make sure you're doing your homework and studying for your test. Your test is on Friday still, which is December 11th. It's on all of chapter 4.